Hello viewers, welcome back to the Multimagic channel. This is session 8 on video series and this will be the last session of the video series for the phase 1, and in phase 2 we will be adding more videos which also includes how to sync both video and audio and generate a real-time applications. In this particular session we will discuss about RTSP file stream using Live555, and we will also go through the retro of the video series, like what we have done so far in the video series. So RTSP file stream using Live555. So Live555 is an open source framework which is used to stream any media related files over the network using RTSP protocol. And in the last video actually we have discussed, actually let me go to that slide once. Yeah, so in the last session we have discussed how to stream a file or stream in camera feed using FFmpeg. So here we are depending upon an RTSP server, which is like a third-party open source framework which I have downloaded. You build it and the application, standalone application is there. So we don't have control over here source code, I mean the server code, but most of the times it's okay. But of course the source code is there. We need to build it and we need to ensure if you want to change you can do that, but it's a different way of doing things also. So in this particular session let's discuss the project called AMR file stream. So where I'll be streaming the file called h264.h264. so this is the sample file. So now we will be streaming this particular file over the network using the Live555. so here I have my, so this is my project structure. So I have Live555 open source framework and all the necessary libs or everything are here. I will share the links in the description where to download this particular framework, and I have an actual project video file stream and I have my solution file here, and this is what this sample file I'm talking. So let's quickly play what is there inside this file. So here I'm playing this file h264. It is just a simple 10 seconds video. Precisely, yeah, just it's just there's no timestamps, but just it plays that particular video. So now we'll be streaming this particular file over the network, and with the help of a VLC player we will see how to read that particular data from the client. So here why I am showing this flavor of code is because here we have a server code and event loop mechanism. So here you have a task scheduler and then it schedules, okay, and then you create sockets RTP and RTCP, and for RTSP for all the things you create socket. So it chooses any random IP address, and this is the destination address. These are all the port numbers. So here you are creating a socket locally, and then from that particular socket you are listening to the different ports and the source ports and the destination ports. So all the source code control is over, I mean the server code is here, and you're telling what is the maximum packet size it is and what is that video sync properties are. So you'll be creating a new environment, and then you'll be creating an instance of RTSP here or RTCP. I mean here you get, so this is the actual beginning of the code. So you will be creating a new RTSP server with the help of Live555 using this particular API create new, and this env environment has few properties like you can see here. So we have declared all the port numbers, scheduler, so everything is associated with that particular pointer. So now you start, so you're also giving these few properties like estimated bandwidth like 500 kbps, and then once this RT instance is created you start the media session actually. So you will be sending this file, whatever this video sync is associated, it starts streaming here from here. So RTSP add server media server, and this for this particular video sync we are telling go to that video sync and open that file. So this input file name, if you can see here, this input file name, it is used to create this particular session, and this particular session is linked to the RTSP server. So it is starts actually streaming that particular file H264 using LIVE555, and there's an event loop. This is a kind of while loop. This is a task. It keeps on continuously in the loop, streams that particular file over and over and over. Please do remember, we don't have any pause or play or forward or backward controls during stream. That is like more of advanced features. We'll be discussing that in phase 2 of the video series definitely. But for now, we will understand the basics of the streaming, like how to stream this particular data over the network. And yeah, these are all the utility functions. Like if you use play, it creates that file, reads that file name, and then yeah, it creates that video source, and it reads frame by frame, and it just starts playing. So this is a simple source code where if you have a file locally, and your server is on the same locally, or if any other server, you can just stream that particular file over the network, and the clients can listen to it and then decode and play it on the VLC player or any other decoder player. So now I have already built this project, but just let me build it again. So the project is successfully built. Yeah, okay, error list, no errors, output, okay, let me rebuild. Okay, it's building, the project is success. So now I'll go here, let me open the command line here. So it is the executable is amr filestream.exe. Okay, so this is the URL clients needs to take care of, so we can, okay, so we need to connect establish. So if you go to media, open, so it's already there, test stream, so just start play. Yeah, so so this plays for like this in a loop. So this stream is coming from the network, from the server, RTSP server, which we created using LIVE555. This particular stream is coming from. So we are not playing the actual file, we are just playing it from the stream, from the server. We are streaming it. Okay, so this is how you stream a file using LIVE555 open source framework. Yeah, so I will share this code in the GitHub, you can go through it. So apart from this, I would also like to go through what we have done so far in the video series. So just like a quick recap, so that way we will remember what actually we have gone through this particular series. So basically we started with few basic video terminologies: what is pixel, what is image, what is frame, and all other details we have gone through, and then we started what is a video compression, and actually compress and decompress with the help of FFmpeg APIs. So we started with this video compression process where a natural scene is in real time. It is divided temporally and spatially, and if you take each block, you just do encoding, and then in the temporal you just take previous frame and the current frame, and you detect the residual frame, and then you do all the DCT and quantization, and you send to the encoder, and finally you will get the encoded file here. So both these things happens in real time. So in between you will get the actual data, actual block, and in between you will get the predicted frame and all other frames. So like this it keeps on going. So this is what we have discussed. So we have I frame, P frame, B frame. So I frame is the actual frame where it is like temporally, or sorry, it is spatially, and temporally you have this P frames and B frames. Yeah, it's true. So we have also seen what happens if B frame size is more. So if B frame value, max B frames value is 1, the compression is less, but the computation time is fast and the size is more. So if the more the value of the max B frame values inside the FFmpeg API codec context, less the compression size, more the computation time. So you have to maintain a trade-off between the computation and the compression, depends upon your requirements. In general, a max frames of one value of 1 or 2, 3 is good enough. So we started with understanding how the value of how B frames, P frames, I frames are very pretty much important in compression and decompression point of view. And later, after gaining a theoretical knowledge on compression and decompression, we basically started understanding the FFmpeg APIs or the FFmpeg architecture. So such that all our real-time projects we do implement in FFmpeg. And see here, this is what actually it does. See, FFmpeg, it has an MP4 file. It has a container. It has a video stream. It has an audio stream. And all these things we declare in a structure. We copy this metadata into AV format context. And we also have two other structures called AV stream. We have a stream separately for audio and video. And from this stream, you will start reading the packets. These are called audio video packets. So this packet can be audio packet or video, or this can, so it's called as AV packet. So now with the help of the decoder, actually, so x260, if it is x264, if this mp4 file has h264, and with the help of this particular x264 encoder, we decode the actual packet, and that packet is now converted into a frame. So this can be audio frame or video frame. In general, we can call it as AV frame. So this frame is now again, so all this process from mp4 file to stream to packet to frame, this particular process is called decoding, and these are all the terminologies related to it in FFmpeg. And the reverse process, so you have a frame, you have an encoder, you encode the data, and you get the AV packet, and from AV packet again you get AV stream, and again you write that into the mp4 file. So this process is called compression or encoding. You have the raw data here, and this particular raw data is compressed and then written into the streams and further into the files, and the decompression is the reverse process. So this is all file based. So this is a lot of APIs we have gone through, like AV read frame, AV write frame. Yeah, as I mentioned, we can see is B frames is like a bidirectional frames, and the number of B frames is trade-off between compression coefficients and encoding complexity. Using too many B frames can increase encoding complexity and reduce visual quality. Using too few B frames can result in lower compression efficiency. So max B frames, here I said if the size is max B frames is 0, you can see here I frames or B frames are more, and this is the size actually. And here the size is reduced a bit because the B frames is 1 B frames. It means like the video file mp4 file is now less size because it is more compressed, but the computation time to decode will be more. Something similar here, max B frames is 3, and yeah, like so on. So like that we understood how this max B frames parameter plays a significant role during compression and decompression of any file format based. So further we started compressing the things actually. So first we started with decompression, like how if there is an mp4 file, okay, and how to extract each frame into an image, how to extract each frame from an mp4 file and convert that frame into an image. So that is our first project we did. I mean, even before that we just played around with that max B frames, how that changing the value of the max B frames has improved our compression efficiency or the size of the file, all those things. That project we started. So this is the second project where we have an mp4 file and we have frames inside this mp4 file, and that frame will be writing into the image. So once this image is there, RGB images, okay. So now this RGB, so what is the process to get RGB image or to convert each frame into an RGB image? So we just, if we read the frame, after reading the frame we get the packets. Just for our understanding point of view, we have written that packets into the file, and later that particular packet we decompressed and we receive the frame here, and these frames are written into the RGB images. Okay, so we have different conversions, AV frame to RGB, how to convert using SW scale libraries, and here we use AV codec libraries of FFmpeg. So using these two libraries of FFmpeg and the internal APIs supported by it, we are converting the MP4, each frame of MP4 file we are extracting it to images. This is the first project, decompression. And the second project is like in compression. This is like, let's say now you have raw images. Let's say for some reason or you have 100 images and you want to make a video of that. So how to convert an images, RGB images in specific to an MP4 file which has video, there is no audio. In the next phase we'll add how to add audio to the video and make it in sync. So here these frames, first we read this particular RGB image and we convert the RGB into YUV data. So YUV have three planes, Y plane, U plane and V plane. So for more details on what is a Y plane, U plane, V plane, it's a particular session, in this particular video, session 4 video, session 3 video, we have the details. So a Y plane is called chroma, brightness, I call these three planes, and what is meant by YUV 420, subsampling, all those things we have explained. So now this YUV data, RGB is converted into YUV, and that YUV data we dump into the AV frame. So now we got from the RGB, we got the frame, the AV frame, and that AV frame is sent to this particular API called AV codec send frame. And while sending the frame, you have to increase the frame pointer, send frame and receive packet. So after sending the frame, we just receive the packet, and then we, after the compressed packet is written into the AV, to the MP4 file. So you have an RGB image, you convert that into YUV, and that YUV data is dumped into the AV frame, and this data is sent to the send frame, and here it compresses the frame and sends the packet, and AV receive packets actually receives that packet here and writes to the file. So this is how you compress raw images to an MP4 file. Okay, so later we moved on to how to, so first maybe I will discuss this and then I can come back to session 6. So in session 6 we how to convert camera frames to RGB images. So instead of MP4 file, here we are getting the feed from the camera, and from that camera we are getting the frame or the packet, and that packet we are sending it, and once the packet is sent, here the compressed packet is decompressed, whatever the codecs we provided in the code, using that, and this decompressed packet or frame is received by this AV codec receive frame. So once we receive this frame, this is the raw data, and here again we are using the convert frame mechanism to image using SW scale library, like using SW context, like all the source code we have shared. So we're converting the frame to image here, RGB image. Okay, so now here we are converting this is like camera frames to MP4 file. So from here, instead of reading each frame from camera and converting into an RGB image, we have, I'm sorry, my bad. So instead of converting an RGB, instead of reading each frame from the camera and converting it to the RGB frame, here actually we are reading each frame from the camera and writing that frame, we are compressing that frame and writing that compressed data into the MP4 file. So for that we need this. So we have a data coming from the frame like this from the camera, and then we have these parameters: read frame, send packet, receive frame, encode, send frame, receive packet. And we need to, the most important thing is like you need to ensure all these parameters are routed to corresponding input and output. If it is a file, how to route; if it is a camera, how to route; if it is an image, how to route. So like all those things you have to take it during initialization things. So all these APIs more or less remains the same, but context, input and output context, you need to play around with. For example, if you see here, you need only the input context because you are reading the MP4. The output context is not because you are writing it to the MP4 file. And here you need only output context because input is an image here. Context means output is an MP4 file. And here you need both input context and output context, because input is from camera and output is to MP4 file. And here you need only the input context, because input context is camera and output context is an image. So for if it is an image, you don't need to specifically mention any context, because you just write that you're writing into a file. If you're writing into a file or an image file, you don't need any context. But if you're writing into an MP4 file, you need a context. And if you're reading from MP4 file, or if you're reading data from the camera, you need an input context. So you need to understand these differences: when to use input context, when to use output context, how to initialize the input context, how to initialize the output context, when to allocate memory, when to free memory, what are the codec parameters, how changing the each parameter, like bit rate, output rate, like all these different parameters, how to play with it. You will definitely able to follow much. You can play around with compression and decompression. So like that. So and in the last session we are now we converted this RTSP file stream. Yeah, this is what we discussed in the this is the last project we did. So this is about RTSP. So instead of just based on the file based, we are doing the network based here. So here we are we have a file and we started streaming, and from server starts streaming. Okay, so the server is the RTSP server, and you can download the RTSP server code and you can run the executable. The server starts, and when you run the FFmpeg code, so we will attach a file to that server. So the server starts streaming that file and the client can view it. Okay, so the client can be RTSP client, which is VLC player of FFplay, and same thing using the camera also. So first we need to start the server, and there is no data sent to the server, and now we need to send the data to the server from the source location, which means my live location. I will send to this particular server, RTSP server, and it starts listening. It starts capturing all the data. All the packets will be received and it kept in the queue, and the client automatically, if you start listening to the server, the client streams receives all the streaming data. Okay, so the server streams the data. It can be a file, it can be a live. Okay, so this is about the RTSP file stream. Okay, and session 8 we already stream file stream using LIVE555. Just in the beginning of the video we discussed. So to keep it very simple, the video in the video basics we have used FFmpeg for compression and decompression, and also for RTSP stream, and we played with input output formats. Sometimes it is image, it is file, it is camera, that what are the adjustments we need to do, and also we also played with a little bit into LIVE555. Actually there is one more session actually that should be part of this particular phase 1 video series, which is nothing about the debugging tools. So you are streaming the data, you are sending the data, but are we really how to cross check whether the compressed data is actually compressed, or we need some debugging tool. So there is a H264 parser is there. So to understand about the parser, we need to know about the null packet, and we need to know about the we need to know about the different things like what is packetization and what is the I mean, like about null packets, what is packetization, what is compressed packetization. So a lot of details we need to cover, so that because we do want to focus more on the product development at this point, you will be receiving more updates about the product from now. And once after a couple of adding more interesting features to the product and releasing it for the Android app and iOS app, definitely I will come back and revisit that particular concept where the debugging tool, how to read the video data in terms of hexadecimal, all those things. Definitely we'll discuss what is null packet, packetization, all those things we'll discuss. So hope everyone enjoyed this video series segment, and I thank all the viewers and subscribers for your feedback. And yeah, see you until the next video. Take care. Bye bye.